Welcome back to the Manufacturing Use Cases podcast. I am Sree Hameed.
And I'm Tim Stuart.
This is our second episode, and today we're going to talk about schedule adherence. Cost and schedule adherence are often the top two KPIs for manufacturing. Schedule adherence is measured at both the corporate level and the plant level. At the corporate level, it is viewed in the context of adherence to the supply chain plan. And at the plant level, it's focused on adherence to the schedule, which can be measured by shift, day, or week. We think of schedule adherence as a composite metric, seeing as how it is highly interdependent with other operational metrics, both at the supply chain level and the plant level. On our first episode, we introduced the standard structure shown here to explore different metrics. For schedule adherence, we're going to connect the dots in a slightly different sequence. As always, we will start with the definition of the KPI, then dive into the root causes. Next, explore the different enablers of the solution. And in this case, we will look at impact finally, which is the business justification for investing in the solution. So let's kick off things by starting with the definition.
Schedule adherence is a measure of how well production actually adheres to the schedule. At a high level, it's calculated based on how many tasks are completed on time divided by the total number of tasks times 100. It can be calculated at the corporate level, where it's against the monthly plan from the S&OP process, but it can also be calculated at the detailed level if you have a detailed schedule being generated at the plant. In terms of who's responsible for it, just about everybody in production and scheduling is going to be responsible. For example, the materials team and the procurement team have a big say in whether things get done on time, with proper quality, etc. But primarily the people who are accountable for it are the production team itself. But since there are many functions that are partly responsible for it and contribute to reaching this goal, there can be pushback from the plant teams that the schedule was infeasible in the first place. In that case, the planning team at the corporate level is going to certainly be held accountable for their portion of that.
Let's talk a little bit about mindset. In our view, consistently achieving schedule adherence is really about a mindset. And that mindset can be summed up as making promises you can keep and keeping the promises you've made. If we think of schedule adherence as simply a KPI, then it is a measure of kept promises, and that's all. In other words, it's a lagging indicator. Any ability to keep a promise is dependent upon whether we made a realistic commitment in the first place. Essentially, if we make unrealistic promises, then we find ourselves in a vicious cycle. If we have the ability to make realistic promises, then we can create a virtuous cycle. This is exactly why capability to promise is the cornerstone of achieving schedule adherence. So in other words, capable to promise becomes a leading indicator of schedule adherence. So keep this concept or principle in mind as we get into the rest of the discussion. Now let's move on to the root cause analysis part. So as we explained in our first episode, we use the Ishikawa method, commonly known as the fishbone diagram, to analyze the root causes. And Tim, let us walk through the root cause summary table now.
Sounds good. One thing you notice here is that we divided up the summary table into two parts. This is the source of variability coming from within the four walls of the plant, or is it caused by factors from outside of the four walls? Doing this helps us better understand why we are failing to attain schedule adherence. Are we given a realistic plan that we're failing to execute with discipline, or is it that we have an unrealistic plan that is set up to fail? It could be both, it could be either, and it often takes an iterative process to pinpoint the root causes. So going with that same breakdown that we had from the Ishikawa diagram, if we start to look at the sources of variability in the process and what's causing that delay, then we can look at the physical or the people sides of things. And are we seeing delays or variability on the machines themselves? Do we have breakdowns in the equipment and so forth? Do we have extreme setup issues that if we're changing products too often is causing us to be delayed? What is causing us to miss times and so forth from a material perspective? Do we have late shipments coming in from our suppliers? Do we have poor inbound material quality? Do we not plan for enough raw material inventory and so forth? From the environment, we may have external disruptions, such as weather events or earthquakes or things like that. And then with respect to method, do we have poor data quality? Are we creating infeasible schedules because the information going into the system is poor? Do we have poor planning, poor material coordination? Do we have functional silos that aren't coordinated with the factory? Do we have no visibility to the constraints or the bottlenecks within the process? From a people perspective, do we have labor shortages or absenteeism that's causing issues with not being able to produce as much as we should? Do we have human error that's causing variability in the process? Do we overproduce on the current setup or run the wrong jobs because things aren't clear? Finally, from a management perspective, is the team getting pressure to schedule too much because there's overly ambitious management trying to push that? Do we have schedule churn with shifting priorities? Or do we have poor communication or poorly enforced discipline within the plant? These are some of the more common reasons for failing to meet delivery objectives. Our goal with this table is to give you a checklist as a starting point for analysis. If you're seeing issues within your plant that isn't on this list, feel free to reach out to us and we can help diagnose what the actual issues are. As we investigate the reasons as to why we fail to meet the on-time in full objectives, we see that other metrics can contribute to the problem. But keep in mind that we're looking to zero in on the time-related root causes here. In other words, if time wasn't a constraint or if you had an infinite amount of time, schedule adherence would not be so challenging. Delays caused by rework, machine downtime, safety incidents, or not having the pressure to expedite shouldn't be a problem because you'd be able to meet all the criteria of a perfect order other than being on time and in full. It's the same time dimension that makes schedule adherence challenging. So as we dive down into the details of this, we're going to be looking specifically at what causes the variability in the amount of time that it takes to deliver the orders.
So in terms of solution design, it's helpful to step back and define an approach. Remember that the principle or mindset from earlier, ultimately this is about, making promises you can keep and keeping the promises made. So in terms of key enablers, what we are really focusing on is the method. So how would we describe the end state vision for this method? In essence, at any given time, we are always working with a plan that is bound by the supply chain reality. And that plan in turn drives the schedule that is bound by the plant flow reality. This is in essence what we are looking to enable through the technology. What we are describing here is an event-driven architecture in terms of how these two parts stay in sync. And that's essentially how one could describe how the digital nervous system is supposed to work, since we've used that concept. Now, the next big question is where to start. And here, the simple answer is look for the constraints. Those familiar with constraint theory know that any improvement on a constraint is an improvement throughout the whole system. And by taking this approach, you also ensure that you deliver value quickly. So with this context in place, let's look at the rest of the solution enablers.
All right, as Sree said, there's a couple of different aspects of this. At the supply chain level, we're looking for how do we smooth out the high-level long-term variability within the operation and how do we create better plans in the first place. And then at the plant level, what we're looking for is what's happening in real time and how do we make adjustments to that to either eliminate those sources of variability, control them, mitigate them, or replan based on what's happening and create a new optimal plan for the organization in near real time. With respect to the machine, we have at the corporate level maintenance programs, machine upgrades, things like that that are going to help us over the long term to eliminate a lot of the different issues that we have from unexpected downtime. At the plant level, we're looking at predictive analytics and asset monitoring to be able to tell us when those things are occurring or when they will occur, and being able to make course adjustments based on that, or at least minimize the amount of time things are down when they are down. From a material perspective, at the corporate level, we're looking at things like supplier qualification, inbound inspection to make sure that the materials coming in are of high quality, and we're getting that supplier qualified so that they're shipping to us materials on time. And then at the plant level, we're looking at things like continuous inventory counts to make sure that we have the materials that we actually think we do. From an environment perspective, at the supply chain level, we have to look at things like disaster planning or resilience planning in order to make sure that we have plans or backups in place when those things do occur. And down at the plant level, from a facility perspective, having monitors or sensors in place that help us understand when high temperatures or high humidity or things like that could be impacting the production process. Next, at the man or person level, we're working on things like worker satisfaction programs, recruiting and retention programs, in order to really keep the staff that we have and keep those positions filled so that we have people showing up every day ready to work. At the plant level, we're trying to control for variation within those processes by having visual displays with digital work instructions, being able to show visual controls of count versus target so that people are doing what they're supposed to be doing. In terms of management policies, improving the S&OP process and making that more real time at the supply chain level is important. And then supporting the continuous improvement culture by doing things like Gemba walks and making sure that people are adhering to the plan as much as possible, and setting a culture where people are empowered to act as problem solvers so that when we identify things that are happening in real time that are creating chaos, our people know how to address that and how to adjust and handle it. So with all that said, let's move on to the final section on operational and financial impact. Keep in mind, the financial justification we show is focused only on the method-related enablers and not really for the machine, materials, environment, or people. From a qualitative perspective, if we look at what are the things that get impacted if we do a poor job or a great job at schedule adherence, certainly the brand promise is going to be impacted very heavily. If we're continuously late, if we don't have items on the shelf, if we're missing deliveries to our customers, those are things that are going to hurt our reputation. Throughput and velocity certainly are impacted if we're not shipping items out the door on time. And agility and responsiveness is very tightly aligned with this concept of schedule adherence. If you have that ability to adapt and respond to changes in the demand signal, then you have a much better ability to respond to those changes. You have a better schedule adherence as a result. On the quantitative side, if we look at the direct labor, certainly there's an overtime impact. If we're having good schedule adherence, we're probably going to be able to do things with less amount of inventory than if we do have that variability and people have those high amounts of overtime to get things out the door. On the warranty and penalty side, if you're shipping late to Walmart, Walmart gives you a big penalty. So it's not as much of a warranty problem as it is a penalty problem. And then from an inventory perspective, if you're having high variability in your supply from your supply chain, you carry more finished goods to buffer against that. So there's also a very high impact there. That is the business case for the key enablers to improving schedule adherence.
So before we wrap up, I want to mention that in a future episode, we'll do a follow-up session on solution design, specifically focusing on how advanced planning and scheduling and MES, manufacturing execution systems, work together to enable the concept of making promises and keeping promises. We'll use an interesting music analogy to convey this idea that advanced planning and scheduling is equivalent to the composer of the feasible schedule. And the MES system plays the role of the conductor that enforces that schedule on the plant floor. So stay tuned for that. That's essentially our episode on schedule adherence. Thanks for listening. Let us know your comments and feedback.